Alright, so let's do the generalization of FLT. This was one of the most requested video. I will not be writing down. I'm really tired by this point, but I hope you understand. अगर कुछ भी doubt आए तो मुझे पूछ लेना उसके बाद, ठीक है? तो the generalization of FLT states that a to the power totient of m is congruent to 1 mod m, where m can be any number, but the given condition is that a and m should be relatively prime with each other, or E and M should have the GCD 1. Now we can prove this only for prime powers. That means only for m is equal to p to the power alpha. Okay, where p is a prime number. Now let m is equal to p to the power alpha. If alpha is 1, then m is equal to p. So a to the power totient of p is a to the power p minus 1, because totient of prime is prime minus 1, right? And it's congruent to 1 mod p, because we know that by FLT, right? FLT का यही तो proof था. It does mean that, right? But the problem comes when alpha is greater than or equal to 2. So for those, we assume that the result is true for alpha minus 1, which means a to the power totient of p to the power alpha minus 1 is congruent to 1 mod p to the power alpha minus 1. ये हम assume करके चल रहे हैं कि ये true है, ठीक है? So let's expand this particular totient of p to the power alpha minus 1. इसका expansion क्या होता है? The expansion of the totient of any power of prime is p to the power alpha minus 1 minus p to the power alpha minus 2, right? And we know that if a is congruent to b mod c, it means that c divides a minus b, right? Or a is equal to b plus kc, where k is any integer, right? Let's put this into perspective. So let's just say that 10 is congruent to 3 mod 7, right? So what have we claimed? We have claimed that a is equal to b plus kc. So that means 10 is equal to, 10 is a over here, b, that is 3, plus 1 into 7, right? So this does hold true. So we just expand this a to the power totient of p to the power alpha minus 1 is congruent to 1 mod p to the power alpha minus 1. Over here, this is our a, this is our b, this is our c from here, right? This is our a, this is our b, this is our c. So c plus k into b. So basically you're understanding, right? So this is the c over here, so c, this is the b over here, so b, and b is actually the k over here. So this is equal to 1 plus b, where b is any integer, into p to the power alpha minus 1. Now what we do is we raise this to the power p and this to the power p, right? On both the sides we raise it to the power p. So when we raise this to the power p, this becomes a to the power p upon power alpha minus p to the power alpha minus 1. This is totient of p to the power alpha, that is totient of m, because m we have assumed it to be p to the power alpha, right? So this is LHS becomes a to the power totient of m. Now what is RHS? RHS is 1 plus b to the power alpha minus 1, b into p to the power alpha minus 1 raised to p. Now we know that, let's suppose we have an expansion that is 1 plus x to the power p. This expansion can be written as 1 plus p choose 1 into x plus p choose 2 into x square, or dot p choose p into x power p. Right? Now all of these terms, p choose 1 into x, p choose 2 into x square, plus till here, but till before this term, all of them have p in it, right? So when you divide this by p, this particular term will be divisible by p, this particular term will be divisible by p. So these would leave remainders 0. But 1 is not divisible by p, and neither is 1 into x power p divisible by p, right? So this is the remainder when you divide this by mod p. So isn't this also similar to this, right? We can assume x to be b to the power p, b into p to the power alpha minus 1, and this is to the power p. So what remainder does it leave? It leaves the remainder, the 1 over here, so 1 over here, into x to the power p, plus x to the power p. So we raise this to the power p, right? So this comes out to be what? This comes out to be b into p to the power alpha, which is congruent to 1 mod p to the power alpha. How is it possible? Let's say that it's 1 plus b into p to the power alpha, right? Now when you divide this by p to the power alpha, and now when you just separate these fractions, we can just say 1 upon p to the power alpha plus b upon p to the power alpha, right? So this is divisible. but this is not. So what remainder does it leave? It leaves the remainder 1. So here it is, right? So we have got the LHS. So RHS. So our LHS was this, RHS was this, and RHS comes out to be this. So doesn't this really prove it, right? It does prove it. Basically, LHS, what's what? LHS we got as a to the power totient of m, and is congruent to 1 mod m, right? Because m is what? M is p to the power alpha. This is the best I could make you understand. I wish you were sitting with me. I would have made you understand better. But phone पे ऐसे recording हो रही है. Just watch this twice or thrice. अगर नहीं समझ आया तो just let me know. I'll make another video on this. ठीक है?